Alright, we are continuing with logarithmic and exponential equations. Right now, we have a problem we need to solve for this guy right here, x. Now, this problem would be very, very, very easy if it was 4 raised to the power of x plus 2 equals 4 raised to the power of negative 2x minus 3. Why would this problem be a heck of a lot easier? Because they would have the same exact one. They have the same base number. And when you have the same base, all you have to do is take this side and set it equal to this side, solve for x, and you're done. Okay? However, we don't have that situation. What's the base of here? That's a base 4, that's a base 6. So we can't do that. So listen, step number 1. When you have this situation, here's your very first step. What I want you guys to do is I want you guys to apply a common log to both sides. Right now, if you write these instructions down in your journal, you will know exactly what instructions to do as you're working through this problem. This is a problem that will most likely be on a quiz, and you're not going to be allowed to use a calculator, so you might want to have instructions of how to do it. So the very first thing you're going to see me do is you're going to see me write log of 4 raised to the power of x plus 2 equals log of 6 raised to the power of negative 2x minus 3. So I applied the common log. Now you could also apply, for those of you who want to know, you could apply the natural log to both sides if you wanted to. I'm just choosing to use the common log. Okay? Now that you've done this, if you have a highlighter or a twistable, I want you to highlight this in a particular color and this in a particular color. I'm just doing orange. Okay? All right, here we go. Step number 2. Use the power property. Bring down the x, which means the expression of x right here. So we're going to take the power property, we're going to use it. We're going to bring that down in front, and we're going to bring this down in front. And this is what it's going to look like. It's going to look like this. I'm going to put in open parentheses, x plus 2. Then I'm going to write times log of 4 equals parentheses negative 2x minus 3 times the log of 6. So I use the power property to take whatever is up here, alright, in the exponent area and bring it down in front on both sides. Alright, here we go. Step number 3. Distribute the common logs with the logs. Distribute the logs throughout the expression. I'm going to distribute the logs on both sides. Distribute the logs on both sides. It's quite easy. Of the equal sign. Okay. So distribute the logs right here. So I have 2 of them, right? Distribute the logs on both sides of the equal sign. So what I'm going to do is I'm going to take this log of 4, that common log, multiply it to the 2, multiply it to the x. I'm going to take this common log of 6, multiply it to the negative 3, multiply it to the negative 2. Alright, now when you do that, here's what's going to happen. This has an x you're going to lead out with the x, and then right behind it you're going to write the log of 4 to lead out with the 2. Right behind it, you're going to also write the log of 4. So notice, the 2 and the x, where do they go? They go right here up front. Okay? Similarly, over here, we're going to do negative 2x, and what's going to be directly behind it? Log 6, good. Go ahead, right, minus 3 log 6. I'm trying to keep things color-coded right here so that hopefully you can see that the negative 2x just went here, the negative 3 went here, 2 went right there, and the x went right up there. Alright, so right now, remember, we are solving for x. So right here, I have a negative 2x with that, and I have a positive x over here. So what I'm going to do, okay, I need to get all of the x's to one side. And the only thing that gets rid of this negative 2x times the log of 6 is I must add a 2x times the log of 6. So both sides. That's the only thing that zeroes this out. So whatever I do to one side, I must do to the other side. Now everybody, these right here, these are not like terms, okay? That's a log of 4 and that's a log of 6, so I can't just add them together and make it 3x. You can't just say 3x log of 10. You can't do that, okay? So what can I do? I can write it like this, 2x log of 6 plus x log of 4. All I'm doing is I'm just taking this right here and I'm just rewriting it as an expression. Over here I have a 2 log of 4. I got to get rid of this because if I put all of my x's on the left side, what do I have to do with my numbers? I need to isolate them and put them over on the right side. So I'm going to say minus 2 log of 4 on this side, which that zeroes out, but minus 2 log of 4 on this side. Now once again, we can't combine these. So since I can't combine them, I'm just going to rewrite them. Minus 3 log of 6 minus 2 log of 4. Alright, so what did I do on that step right there? What I did was this. Alright, I isolated all of the x values. Isolate all x values on one side. Which means if you do all the x values on one side, you must do all of the numbers on the other side, the rest of it. It doesn't have to have variables of x. Now, I have an x right here, and I have an x right there. Alright? So right now, I just want to solve for one x. I don't need an x here and an x here. So here's a cool thing that you're allowed to do. In this expression right here, and in this expression right here, what's the only number that they have in common? X. Alright? Which means this. Here's step 5. Factor out the x. This right here is probably the most important step, is knowing how to factor out the x. Here we go. I'm going to factor it out. I'm going to open up a set of parentheses. If I factor out the x out of this expression, all I have left is a 2, a log, and a 6. So 2 times the log of 6. If I factor out the x out of this expression, what do I have left remaining? Log 4. Good. Now, we had 2, right? Now we factored out. Now there's just 1 left. Okay? Now this is equal, everybody. This is still equal. This has not changed. This is still equal to this. We have not used a calculator, 1 iota. Okay? Now, if if I want to solve for x, the very, 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 very final step is to do one last thing. Divide on both sides. Divide on both sides by what? Divide on both sides by this expression. Okay? So we're going to divide this side right here, and we're going to divide this side right here by 2 log of 6 plus log of 4. 2 log of 6 plus log of 4. Because these will cancel out to a 1, and x is equal to this right here. That's what x, that's your exact answer right there for this problem. Now, we're going to find the approximate answer right now together. Okay? We're going to take this and we're going to carefully type it into the graphing calculator and find the approximate value that it goes with. Alright, we need to turn our graphing calculators on. Okay. Hit alpha y equals enter. Type in negative 3 and minus 3, so I can negative 3. What was it, log of 6? Is that right? Is it minus? Minus 2 log of 4? 2 log of 4. In the denominator, is it 2 log of 6 plus the log of 4. Okay? Now when you guys type this in and press enter, this is the approximate value that you get. You get this right here. That's your approximate value for x. So your approximate value for x is negative 1.639. This is your approximate answer. This is your exact answer. Now, everybody, if you go to your graphing calculators and you hit y equals, right here, would you guys agree that these were the two? Oh, hold on. Go down. When we started out, these were the two equations, right? 4 to the power of x plus 2 had to equal 6 to the power of negative 2x minus 3, right? And what did we get for x? We got negative 1.639. That's what we would have to plug in. Now, if you guys are taking a test, and I am allowing you to use the graphing calculator, so you know what? You got a lot of questions to do. Use the graphing calculator on all of these questions, and I don't take the calculator away. If I take the calculator away, what do you got to do? You got to do our process. If you are allowed to use the graphing calculator, here's what you can do. You type it into y equals. Okay? You hit graph. You see where the graphs intersect. And wherever the graphs intersect will be your answer. Now, how do I find this point of intersection right here? You hit second. Trace. Find the point of intersection and press enter 3 times on this particular graphing calculator, TI-84 plus CE. What do you guys notice that the point of intersection is at? Second. The graphing calculator will not give you the exact answer. It will give you your approximate answer. So if you're allowed to use a graphing calculator, now listen, don't let this be a crutch. I'm not showing this to you so you can just go through and just type in the graphing calculator. Because you're going to have a quiz where you have to show the work. Right? But you can use your graphing calculator to do what? You can check your answer. Alright, we have one more problem to do today. That's problem number 11. You guys are going to start doing this on your own. Okay? Problem number 11. I want you guys write this one down in your journal. This is the last one we're going to do today. And then the rest of it you're going to have to do on your own. Alright, here we go. Step number 1. Number 1. I want you guys to write the letter U. We're going to use the letter U again. U is going to be equal to e to the power of 3x. You're like, wait a second, Mr. Moody. Yesterday, U was equal to e to the power of 2x and e to the power of x. Well, we're adapting. All right? We're adapting right now. So wherever I see e to the power of 3x, what am I going to replace it with? A u. But minus 17u, because you can clearly see that e to the 3x right here. Right. Changing it to a what? Changing it to a simple letter to work with. Okay? Plus 7 equals 0. Now, right up here, I want you guys to look at things a little bit different. You see the 6 and the x? I can actually write 3x times 2. E to the power of 3x times 2 is the same as u. Yeah. So right here, you guys see this? What am I going to replace that part with? I'm going to replace it with a u. What I still put x, what do I still have up there? 2, right? So this is going to be 6u squared. Okay, now what kind of equation do we have? We have a quadratic equation. Now, does anybody remember the quadratic formula? All over 2a. Alright? Now, this right here, if you automatically look at it and you're like, I'm not sure if this is factorable, okay? It is, but we're not going to factor it, but it is factorable. But if you can't recognize that, just use the quadratic formula and get it done. So, what's my a value, everybody? Good. B. I like it. And C. Got it. Good job. First thing we're going to do is always find the value of the... Yes, the discriminant. There's the discriminant. We're going to find that value right now. We're going to find it because we're going to take negative 17 squared minus 4 times 6 times a 7. If we only knew what negative 17 times negative 17 was. Oh, how did I say? Oh. You said negative, yeah. But 289, because the negative times negative is a positive. You got 289 now. Let's think here. We've got a 4 times a 7, which is 28, times a 6. Or we could do 6 times 7, which is 42, times 4. That might make it easy. Ooh, that makes it easy. 168, right? 168. If we take these away, we are refusing to use a calculator right now. We refuse. All right? We're using our brains. All right? We got a 1. We got a 2. We got a 1. Why am I happy about this number, Josiah?
Because that's 11.
Yeah, it's 11 squared. That's right. That's why we like it. So right now, here's what I want you guys to do. It says negative b. What is our b value? Negative 17. So we're going to rewrite it. Here we go. We're going to say 17 plus or minus the square root of 121 all over 2 times my a value, which is a 12. There's everything plugged in. Now, Josiah, you said the square root of 121 is an 11. So here's how we separate our two answers. Right? 17 plus 11 over 12. And 17 minus 11 over 12. We've got a 28 over a 12. We've got a 6 over 12. That's a half. That's 7 over 3. Divide those both by 4. So what do we have? U equals what? U equals a half. And U equals 7/3. So we got 7/3 and a half. Now yesterday, we made a huge point. Bailey, you weren't here? Or right here. If this number or this number are negatives, if they're ever negatives, stop working on the problem. Because it's no solution. Whenever these numbers right here are negatives. Here's why. What did we say u is equal to this time? We said u is equal to e to the power of 3x. We have e to the power of 3x equals a horrible looking 7. That's better. Over 3. And then we have what? E to the power of 3x is equal to a half. Now what I was saying was this. If you ever get e to the power of 3x equals like a negative 2, you can't solve it because there's no number here that can somehow make it magically a negative number. You can have negative exponents, you just can't have negative answers. Alright? Now, yesterday we talked about the natural log of e always equals the number 1. The natural log of e always equals the number 1. We also said the natural log of e to the power of x always equals x. If I say the natural log of e is I am so bored, the answer is I am so bored. Hopefully that's all. If it is, well, you'll laugh. Alright, so what we're going to do next is we're going to, big step right here. Big step. I realize we didn't do it step by step, Jay, I apologize, alright? But here's your biggest step. At the very, very, very end, apply the natural log to both sides. So we're going to apply the natural log to both sides. So here's what you're going to see. You're going to see the natural log of e to the power of 3x equals the natural log of 7/3. That's one of those that you're going to see. The other one that you're going to see is the natural log of e to the power of 3x equals the natural log of 1/2. Alright, now, everybody, what did I say the natural log of e to the x is always equal to? It's always equal to x. So what would the natural log of 3x equal? It would equal 3x. Okay? So 3x equals the natural log of 7/3. Now that still doesn't make sense. One thing you guys are pretty good at. You're pretty good at understanding that you can use the power property, right? So the power property says what? It says that I can take this and move it where? Move it up front. So I'm allowed to move it up front. Now, what is the natural log of e always equal to? A 1. So if I wrote, okay, if I wrote 3x times the natural log of e, what is this part right here always become? What is the natural log of e always equal? Yes. So what is 3x times a 1? It's just a 3x. That's why I just have a 3x now. Okay? So right over here, I also have a 3x equals the natural log of 1/2. So the final step to solve your problem is divide this side by 3, divide this side by 3, but instead of dividing, I'm going to multiply by 1/3. So I'm going to multiply both sides by 1/3, and I have 1/3 of the natural log of 7/3. And over here, I have 1/3 times the natural log of 1/2. Now, on your calculator, it's going to look like this. When you guys type it in the calculator, you're going to get 2 answers. This, honestly, this equation has 2 answers that work. This answer and this answer. So we're going to type those in right now so you guys can find your final approximate answer. Or I'll go back. Clear this out. I said it's 1/3 of the natural log of 7/3. That's one of your answers right there. I also said it's 1/3 times the natural log of 1/2 right here. These are your 2 answers that work. We're going to round it to the nearest thousandth, which is the 3rd decimal place. Those are your 2 approximate values. All right, 0.282 and negative 0.231. Now, our original equation was 6e raised to the power of 6x minus 17e to the power of 3x plus 7. And I'm telling you, if you take this and plug it in for x right here, and if you take this guy and plug it in for x, they will both equal 0. So you have two answers that work. That's why we're writing down two answers. I'll go back right here, very, very, very bottom. There's the final steps.